Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous video, I have actually covered the fourth chapter of 9th standard mathematics that was on linear equations in two variables. So in this particular video, we will look into the new chapter that is on introduction to Euclid's geometry, which is the fifth chapter of 9th standard mathematics. So now, before going into the introduction to Euclid's geometry, first we will try to understand what do you mean by geometry. So here, in order to understand this word geometry, you have to split the word into two words. One is geo and the other one is metrian. So these two words are derived from Greek language. And here geo means earth and metrian means to measure. So that means here basically measurement of earth. So why they have given this geometrian as the name for this geometry is because the main problem which people faced in those days were the issue of measuring the lands, because during Egyptian period whenever there is an overflow of Nile river, so for example if there is a Nile river, so if there is overflow of this particular Nile river during rainy seasons, so the people who are staying beside that Nile river had some agricultural lands and they had some defined boundaries. But whenever this Nile river overflows due to heavy rain, then all these boundaries was erased. So when that boundaries of agricultural lands were erased, again they have to take help of something to exactly calculate the boundaries of their lands. So for example, if this is a big chunk of land and all these small portions are one agricultural land, so here if the boundaries is erased, then again we require something, some subject knowledge is required in order to re-establish these boundaries and re-establish the amount of area which each person had owned. So for that we want this particular geometry's help. So that means here measurement comes into picture. So now land means this land is nothing but it is a piece of earth. So that means here measurement of the earth or the measurement of the land is done. So that's why this particular name was given as geometrian. So that means basically you are measuring the land. So slowly measurement of different shapes, measurement of different objects. So starting from the measurement of land, slowly the same geometry was used to measure so many different objects, so many different shapes which are there around us. And there is something called truncated pyramids, so which looks similar to this particular image which I am drawing here. So in order to calculate the volume of this kind of truncated pyramid, even Egyptians used a particular formula which actually gives the correct volume of this kind of truncated pyramid. For that they used the length of the bottom part of the pyramid, which is A, and the length of the top surface of this particular pyramid, which was B, and they took the height of this particular pyramid and they incorporated all these terms into a formula to calculate the total volume of this particular truncated pyramid. So why I am giving this example is because, so the geometrian, the word geometrian, which was derived from the Greek language, where geo means earth, metrian means the measurement. So that means to measure the land, whatever you have. So initially the measurement which was done for the land, slowly the measurements were done for different objects which were there around us. So this is one example. This is one object of which they calculated the total volume of this particular truncated pyramid. So this is just one example. So even in India, when there was Harappa and Mohenjo-daro civilization. During that period also, if you carefully look into the architecture of this particular civilization in those areas, even today you can see that there are so many parallel roads in that particular civilization, and there is underground drainage system, and there is well built structures. So in order to build those structures, they have exactly used same sized bricks, where the ratio of this bricks was calculated to be 4 is to 2 is to 1. So that means this precise shaped bricks and identical bricks were used to construct the structures in this particular Harappa and Mohenjo-daro civilization. And also roads were very much parallel, and the areas which they had built to stay, that was also very systematically planned. Unless and until people having knowledge about geometry, they cannot build this kind of structure. Like they cannot build a proper planned city, and also they cannot properly construct beautiful structures. Clearly shows that Indian civilization, like Harappa and Mohenjo-daro civilization, has used the geometrical concept properly. Only when they have knowledge about geometry, then only they can build this kind of very advanced civilization. So that means even this is a proof that even in ancient India, the use of geometry was there, and also in ancient Greek, the use of geometry was there. And also there are so many examples in different scriptures which are there in Indian culture. So in those scriptures, they have actually given some sutras that were known as Sulabha Sutras. So those Sulabha Sutras were used to exactly calculate the surface and volume of certain object. So using this Sulabha Sutras, various geometrical constructions were done. So using this Sulabha Sutras, so these Sulabha Sutras were existed around 800 BC to 500 BC, and these were used in order to construct the geometrical constructions. So that means even in ancient India, people were widely using geometry in order to construct various constructions. Why we are discussing about these examples is because this shows human beings have heavily dependent on this particular geometry in order to construct various things which he has constructed around us. And whatever the knowledge people had on geometry were very much crude. That means it was not well organized. So people were using the knowledge of geometry orally. Like for example, if one person has knowledge of geometry, then orally he used to transfer that knowledge to another person, and that person was transferring that knowledge to another person. So that means there was no systematic organization of the knowledge of geometry. So that systematic organization of this particular knowledge related to shapes and knowledge related to calculating areas, volumes of different shapes, different objects. So in order to have a proper systematic knowledge about all these things, Euclid and various other mathematicians organized this in a proper manner. So and there were famous mathematicians who discovered so many theories related to geometry. Like for example, Pythagoras was there, Thales was there, and various other mathematicians were there who developed their own theories in geometry. But the thing is, all these theories in geometries which were used across the world were not well organized. So that's why Euclid, after 300 BC, when Euclid came, he organized the various concepts which are there in geometry. Euclid organized all these theories which were there in a particular treatise which was known as Elements. So in this Elements, again he divided this into 13 different chapters. So he divided these Elements into 13 different chapters. So most of the concepts he actually summarized in 13 chapters. And even today we can follow these 13 chapters and also connect this with the modern day geometrical concepts. And Euclid also gave the names, different names for a particular solid objects. He told every solid objects have shape. So every solid objects have its own shape, it has its own size, and it is located in a particular position. And this particular solid object can be shifted from one position to other position. So this particular solid object can be shifted from one position or from one place to another place. And all these solid objects have surface. So he came up with another term called surface. So every solid objects, have its own surface. So these surfaces are the boundaries of these particular solid objects. So these boundaries of a particular solid object separates one part of the space from the other part of the space. And one thing you should remember, this particular surface do not have any kind of thickness. They don't have any thickness, and this surface can be curved surface or it can be a plane surface, and this surface is strictly restricted to that particular object only. And that surface divide one part of the space, separate one part of the space from another. So this is all about surface, and this surface term was also coined by this particular mathematician Euclid. So always remember, surface has two dimensions because surface doesn't have any thickness. Because it doesn't have any thickness, the third dimension is not there. So that means surface is always a two dimension, and a solid object is always having certain amount of extension in x, y, and z axis. So that means there is a certain amount of extension in all three dimensions for a solid object. Hence, solid object is a three-dimensional object, and a line is extended only in one particular dimension. Hence, line is a one-dimensional image. So hence, line is one-dimensional. And if you are just considering a point, point is dimensionless. So logically speaking, point might be dimensionless, but logically point also has some amount of dimension, because here point also occupies some amount of space on this particular image. So here if I am writing a point, means this point is also occupying some amount of space on this surface. So that means here point also on a miniature level, on a very small level, this particular point also has some dimension. But in order to make calculation easier, we assume that point is dimensionless, line is one dimension, solid object is three dimension, and a surface is two dimension. But remember, when you logically think, point also has some dimension, but that dimension we are neglecting during the calculations, because whenever you are constructing a particular house or if you are constructing a particular bridge, then if you are considering the dimension of a particular point, a single point, then you cannot proceed with your calculations. In order to proceed in our calculations, in order to go ahead in our calculations, we are sticking to the idea where we are considering point as dimensionless, line as one dimension, solid object as three dimension, and surface as two dimension. So just for the calculation purpose, we are defining this. So, and one more thing you should remember here, surface has length and breadth. So surface always have length and breadth. Solid objects always have length, breadth, and height. Line has only length, it doesn't have any breadth, and point doesn't have any kind of length, breadth, or height. This is all there in this particular video. I have given some basic understanding about geometry and about this particular chapter, Introduction to Euclid's Geometry. So in my next chapter, I'll be discussing about axioms and postulates, including examples, which is there in this particular chapter. So until then, if you want to learn more physics, chemistry, and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.